Hey everybody, so today we're going to be talking about trig equations with different periods now. So the trig functions that are inside our equation will have different periods other than 2 pi. So now make sure you do have your unit circle around you because we will be using it again today. And what we're going to see today is that what we were doing last time can be adjusted to fit this new type of trig equation, ones where, again, the period's not 2 pi. So our goal for today
is to adjust your problem-solving strategies to take into account trig functions that have
different periods. Okay. But what's nice about this is that we're still using the same process that we developed last time. We're just adding a couple more steps. So solve the following equation for theta in 0 to 2 pi. So like we would do last time, you want to make sure that you read the question carefully and understand where is theta allowed to be. Okay, so in this case, theta is allowed to be in 0 to 2 pi, so our standard unit circle. Next, look at your trig equation. What trig equation or what trig function are we dealing with? Notice here we're dealing with cosine. So what does that mean for the unit circle? That means we're going to be looking at the x-coordinate. Okay. Now this is where we're going to start to diverge a little bit. Now what we want to do is figure out, okay, what's the period of this trig function? So remember, we take 2 pi, divide it by whatever number's in front. All right. And so we get pi in this case. So this trig function has a period of pi now, and we're going to use that later. So I'm just going to bubble this really quick and keep that in the back of your minds. All right, next, we do what we would always do, isolate the trig function. Okay, so to isolate the trig function, let's add 1 to both sides. So we get 2 cosine of 2 theta is equal to 1. Divide both sides by 2. And so now we get cosine of 2 theta is equal to 1/2. Okay. All right. Next, we use the unit circle. So now we're going to look for when is the x-coordinate 1/2. Although we're going to have to see, we're going to have to be a little careful. But in the meantime, when is the x-coordinate 1/2? So we look at our unit circle. When is the x-coordinate 1/2? So we have here at pi over 3, and here at 5 pi over 3. Okay, so remember that, pi over 3, 5 pi over 3. Okay, now normally what we would do is we would say theta is equal to pi over 3 and 5 pi over 3. But notice we don't have a theta inside here, so we have to be a little bit more careful. We have to say that 2 theta is equal to pi over 3 and 5 pi over 3. So solving for theta, we get theta is equal to pi over 6 and 5 pi over 6. Okay. Now what you guys saw, and I remember you're visualizing trig equation solutions, remember when the period has been adjusted, we might have more solutions. In fact, we are going to have some more solutions that we don't have here. So how do you find the other solutions though? Okay. And that brings us with our last step. We add multiples of the period to get the other answers. So what I mean by that is we're going to take pi over 6, and we're going to add, remember, what's the period of this trig function? It was pi. Okay, so we're going to add pi to this. Now, what is pi over 6 plus pi? That's 7 pi over 6. And then we want to ask ourselves, is 7 pi over 6 in this interval here, 0 to 2 pi? And the answer is absolutely. So here's another solution that we didn't have before. Do the same thing with 5 pi over 6. Okay, we're going to take 5 pi over 6, our solution right here, add pi to it. Okay, and in this case, we'll get 11 pi over 6. And then we ask ourselves, okay, is 11 pi over 6 in this interval still? The answer is absolutely. So this is okay too. And now we're going to repeat the same process with these 2 new solutions that we found. Okay. So we're going to take 7 pi over 6, add pi. What do we get? We're going to get 13 pi over 6. Now, when we ask ourselves, okay, is this in between 0 and 2 pi? Note that 2 pi is also 12 pi over 6. So 13 pi over 6 here is too big, so we're going to stop. We can stop with that part. And just to double check, Let's take 11 pi over 6 and add pi. And if we add that, we're going to get 17 pi over 6. And again, that's too big. So we stop there. So what are the answers that we have? We have pi over 6 and 5 pi over 6, which we got pretty much directly from the unit circle. And then by adding one multiple of the period, we got 7 pi over 6 and 11 pi over 6. So let's write that down. So theta is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay. So again, the process is almost exactly the same as the process that we developed last time, except we have to check that we don't have other solutions by adding multiples of the period to our solutions. And again, once you get too big, you can stop. You're good. Let's look at another example. So solve for sine squared of 3 theta minus 3 is equal to 0 for theta in 0 to pi. Okay, so notice now our thetas, our angles, have to be in the top half of the unit circle. Okay, so we're dealing with sine in this case. So we're going to be looking for y coordinates. Let's go ahead and isolate our trig function. So let's move the 3 over to the right-hand side. Whoops. Okay, divide by 4. And we get sine squared of 3 theta is equal to 3 over 4. And then now we take the square root of both sides. But remember, when you take the square root, to be a little bit careful. Okay, and so we get sine of 3 theta is equal to plus or minus the square root of 3 over, and notice what's the square root of 4? That's 2. So we have sine of 3 theta is equal to plus or minus square root 3 over 2. So now we look at our unit circle and we figure out when is the y coordinate plus or minus square root 3 over 2. Okay, so again, when is the y coordinate plus or minus square root 3 over 2? Okay. So if you look at your unit circle, you'll see you'll get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So all of our pi over 3's in this case. Now again, we can't just say theta is equal to these multiples of pi over 3. We have that 3 theta is equal to all of these. Oops, and I missed one. Okay, so what's theta equal to? Theta is equal to pi over 9, 2 pi over 9, 4 pi over 9, 5 pi over 9. Okay. Now again, these might not all be all the solutions, so we have to double check. Okay. So remember, what's the period of this trig function? The period is 2 pi divided by 3, which, since all of our denominators have 9 here, I'm going to convert this into, let's see, 6 pi over 9. So what we're going to do is we're going to add 6 pi over 9 to these answers, and we're going to make sure that they're within 0 to pi. Okay, so if we take pi over 9 and add 6 pi over 9, so the period of our sine function in this case, we get 7 pi over 9, which is definitely within 0 to pi. So that's okay. Take 2 pi over 9. We're going to add 6 pi over 9 to that. That gives us 8 pi over 9. Check. Take 4 pi over 9. Add 6 pi over 9. And now we have 10 pi over 9. Now notice this is bigger than pi. So now we start to throw away things. We don't want that. And just to double check, what's 6 pi over 9 plus 5 pi over 9? That's 11 pi over 9. And again, that's too big. That's bigger than pi. So we throw that out. So our solutions here are all of these plus the two new ones that we just found. And we have our answers. Okay, so again, just to reiterate, when you have a period adjustment in your trig equation, the process is exactly the same, except once you've used the unit circle, you might have to add multiples of pi, or of your period, the new period, to your answers to see if you get other answers. So just be careful with that.